In this lesson, we're going to talk about some of the vocab that has to do with circles in terms of the line segments and arcs that exist in the circles. So starting off with our line segments, there are several segments. Some of them you are probably familiar with, but some of them you might not be. So the first thing we're going to talk about is this point right here in the middle. So this point in the middle is the center of the circle, and it's pretty important to some of these line segments. So the segment that goes from the center out to the edge of the circle is called the radius. And so no matter how you draw this radius, where you end up on the circle, the radius is going to have a constant length. So from the center out to the circle, anywhere on the circle is going to be the same. The next line segment is going to go from edge to edge of the circle, but go through that center point. And so whenever you have that line segment with endpoints on the circle, but it goes through the center point, that is a diameter. So the diameter is made up of two radii going in opposite directions, and so it will be twice the length of the radius. So those are probably some terms that you're familiar with, but you might not be familiar with the terms for these other segments. So we're going to start with this segment that has two endpoints on the circle but does not go through the center. So if we look at this segment here at the bottom of the circle, notice that it has an endpoint at each end, and those are both on the circle. So this is called a chord. So the diameter is also a chord, but it's a special chord because it goes through the center. A chord can be anywhere, any length, and we just call it a chord if it doesn't go through the center. The other two over here are lines, not just segments. They go past the edge of the circle. So this first one hits the circle at exactly one point and then continues going in both directions. So this line is called a tangent line. That is different than the tangent ratio. So this is a tangent line. And this point where it touches the circle, it touches at exactly one point on the circle, and this is called the point of tangency. So the other line, which goes past the edges of the circle, but it hits at 2 points, this line is called a secant line. So the secant line touches the circle at 2 points. So what we're going to do is we're just going to look at another example and decide what kind of line or segment each of these are. So here, our first one to identify is segment AH. Notice that it has two endpoints outside of the circle, but it hits at exactly one point, point B. So because of that, this is a tangent line, or a tangent segment. Next, we're going to look at segment EI. So segment EI, both of those endpoints are on the circle, and it goes through point C, which is the center of the circle. So this is a diameter. The next segment is segment DF. And DF has endpoints on the circle, but it does not go through the center. So this is a chord. Next we have segment CE. So C is the center of the circle, E is a point on the circle. That makes that segment a radius. The next segment we're going to look at is HG. So H and G are both points that are exterior to the circle. They are outside, but it does hit at 2 points on the circle, J and E. So since it hits 2 points, that is a secant segment, part of a secant line. And the last one we'll look at is JE. So JE is that segment that runs from each edge of the circle, but it does hit those 2 points. So this is a chord again. All right, so next we're going to look at the angles and chords that are created by those line segments. So identifying what kind of segments we're working with will help us figure out what kind of angle or arc we're looking at. So first, if we look at this line that is exterior to the circle here, we can see a tangent line is drawn. So that's going to be important once we get to working with those different arcs and angles. So we're going to start with the angles that are created inside of the circle. So the first angle that I notice here is located with these endpoints on the circle, and then this vertex of this angle is at the center. So since the vertex is at the center of the circle, this is called a central angle. And so the important part is that the vertex of a central angle is the center of the circle. And then there's another angle with those two same endpoints, but on this next angle, the vertex is on the circle. So it starts at each edge of the circle, hits the vertex, which is a point on the circle, and then goes back to that same endpoint. And since this one touches the circle with the vertex, this is a inscribed angle. There is a relationship between the central angle and the inscribed angle that we'll talk about in this unit. So notice that since both of these opened up to that same little piece on the edge of the circle, this is the first arc that we're going to talk about. So arcs are pieces of the circle, not the entire circle, but we're just going to look at one little curved portion of the circle. So this first arc, it's less than 180 degrees. It goes from one endpoint to the other. So this is called a minor arc. So minor arcs are less than 180 degrees, which would be half of a circle, and they would be named with 2 points. So let's throw some letters in here to talk about these different things. So I'm going to name the center of the circle C, and then I'll use A, B, and D for these others. So looking at this arc, this minor arc that we're talking about, this one goes from A to D. So that's going to be the minor arc AD. I just use 2 letters, and then this little cap that goes on it tells me that it's an arc. So that's part of that notation. So if I add some notation now that I have points, the central angle is still an angle, so I would use the angle symbol, and then I would name it with those 3 letters that create it, A, C, and D. So angle ACD is the central angle in this figure. And then my inscribed angle is angle ABD. So both the central angle and the inscribed angle shown here open up to that minor arc AD. So if the part that's less than 180 degrees is called the minor arc, then the other portion of the circle, which is going to be more than 180 degrees, so this outside portion, this is called the major arc. So since there is more of the major arc, we use more letters to define it. So it still has those same end spots, A and D, but it goes through point B. So I'm going to name the major arc with 3 letters, A, B, D. And so a minor arc can be named with 2, but a major arc has to have at least 3. So those are the angles that are created. So notice if we talk about the segments that make these, the central angle is made up of 2 radii. So AC and CD would both be a radius of the circle. So just to get used to those vocab terms, this is a radius, this is also a radius. The inscribed angle, it could be made up of a diameter, but neither of these are diameters because they don't go through the center. So since they have 2 endpoints on the circle, this inscribed angle is made up of 2 chords. So next what we're going to look at is how this tangent line plays in. So the tangent line is creating an angle with this chord AB that intersects the tangent line. And so the angle that's created there, the angle that's created by the tangent line and the chord and where they meet up, this is called an intercepted angle. So this angle that goes from the tangent line down to the chord is an intercepted angle. So there's also a chord that's created there, and that chord created there goes from point A to the other endpoint of that chord, B, and so the chord created there is going to be called an intercepted, or the arc, intercepted arc. So AB, also less than 180 degrees, so it would be another minor arc, so it is named with 2 letters. So that's our intercepted arc of this figure. So now let's look at another diagram that's drawn similar way. So we have segments inside the circle. LN and NM are chords. LO and OM are radii. And then I am going to add in a tangent line here through point M. And on that tangent line, I'm going to add another point. And this point, I'm just going to name it P so that I can get some names of these different things. I'm also going to add another vocab term down here, and that's going to be an inscribed angle. So we're going to identify these pieces, some of these pieces, based on the diagram that we're working with. So let's start with a minor arc. So a minor arc is an arc that is less than 180 degrees, less than half the circle. So one minor arc that I see here runs from point L to point M. And so I'm going to name that minor arc with 2 letters and put the cap on it. So that is arc LM. So since I use that as my minor arc, I'm just going to look at the other side for the major arc. So it's still going to stop at L and M, but I need to name it with at least 3 letters. So this is going to be arc LNM, because N is also a point that's on that arc. All right, the next thing we're going to look at is the intercepted arc. So that's created by the tangent line, and that's going to be where the tangent line meets the chord that touches it. So this does need to go all the way across the circle. So if I'm looking at this one, I'm going to go from P to L. First, I'm going to find my intercepted angle so that can help me figure out my intercepted arc. So the intercepted arc, or the angle, is going to go from P to L and then down the chord, and the chord goes from L to N. So based on where I put this point, I have my intercepted arc, or my intercepted angle first is going to be angle PLN. So P to L is on the tangent line and L to N is a chord. All right, next is going to be the intercepted arc. So based on that angle and where that angle opens up, it's on the right side of this circle. So I'm going to go around the circle until I meet that other endpoint of the chord. So for this chord, it is more than half of the circle. Half of the circle would go right from through that center. So this is more than half of a circle. This is a major arc, so I need to name it with at least 3 letters. So this intercepted arc is going to be LMN. If I had put that point P on the other side of that tangent line, I would have created a minor arc. All right, next we're going to look at the central angle. So my central angle is going to be created by 2 radii that meet at the center point. So if I see these 2 radii, LO and OM, that creates my central angle. So the name of my central angle here is going to be angle LOM. And then the last thing I need to name is my inscribed angle. So the inscribed angle is going to have a vertex on the circle, and it's going to be created by chords. So LN is one chord, NM is another chord. So the angle that's created there is angle LNM. So we'll look at the relationships that are formed by these angles and arcs and segments. And so our vocab is going to be really important to being able to identify the pieces that we're working with.